So far, we defined the length of parametric curve and we saw the sketch of proof behind it. We saw that if we have a curve like C, which is defined parametrically by x equals to f of t and y equals to g of t, it means that your position x and y depends on parameter t, and t is bounded between a and b inclusive, where f prime and g prime are continuous and not simultaneously zero on a and b, and c is traversed exactly once as t increases from a to b, then the length of c, or this curve, is defined as definite integral. We say that L is the definite integral from a to b of the square root of f prime of t to the second plus g prime of t to the second dt. We also saw that with a proof that if y is a function of x, it means that there is no parameter involved. We can calculate the length of the arc as well. Let f have a continuous first derivative on the interval a to b, which is a closed interval. The length of the curve from a and f of a to b and f of b is L, which is the definite integral from a to b of square root of 1 plus f prime of x to the second dx. In this example, you want to find the length of the curve f of x, which is x to the power 3/2. X starts from 0 and it stops at 4. We can visualize this curve as well. Here, when x is equal to 0, your y is equal to 0. When x is 4, your y is 8. We want to know what is this length. How do we calculate this length? Remember that your function f of x, which is x to the power 3/2, has derivative f prime of x, which is 3/2 x to the power 3/2 minus 1, or a half. The length of the curve from a to b is the definite integral from a to b, the square root of 1 plus f prime of x to the second power dx. We have all the pieces of information. We just need to plug in and simplify as much as we can. So L is equal to the definite integral. Our x ranges between 0 to 4, the square root of 1 plus the derivative that we calculated is 3/2 x to the power a half. So we just substitute that and raise it to the second power. Then we take the integral with respect to x. Let us do a little bit of algebra. This is equal to the definite integral 0 to 4 of square root of 1 plus 9/4 x to a half raised to power 2. 2 on the numerator, 2 on the denominator, they get cancelled out. So you're left with x, then dx. To calculate this integral, you can use usolve. This integral is 4/9, integral 1 to 10. Remember that since you have a quantity inside your square root, you can use usolve. U is 1 plus 9/4x. So this quantity is square root of u. And for dx, du is equal to 9/4 dx. So dx is du times 4/9. So again, wherever you see dx, you're going to use 4/9 du. That's how you end up with this 4/9. And since your x equal to 0, if you plug that in here, your u becomes 1. And when x is equal to 4, you plug that in here, you get 1 plus 9 equals to 10. That's how you end up with 1 and 10 as the lower bound and upper bound of the integral. Now, this is equal to 4/9, 2/3 u to the power 3/2, and u ranges between 1 to 10. In turns, it's equal to 8/27 10 to the power 3 halves minus 1. If you use a calculator, you get approximately 9.1 units as the length of this curve.